Press on the right side of the screen to enter the NanoVNA main menu. Select Stimulus to configure the frequency range. Select Start/Stop. Start should be 1 MHz and stop 800 MHz. Each demo has its own specific frequency range. Check them on GitHub. Press on the right side of the screen to select Back to return to the main menu. Select Cal to enter the calibration menu and select Reset Cal. To clear any previous calibration data, it is important to start with a clean slate for accurate measurements. Select Calibrate to start the calibration process. Connect port 1 to the Open Calibration Standard on the UMSAKAZO board, then select Open on the NanoVNA screen to perform the Open Calibration step. Connect port 1 to the Short Calibration Standard on the UMSAKAZO board, then select Short on the NanoVNA screen to perform the Short Calibration step. Connect port 1 to the Load Calibration Standard on the UMSAKAZO board, then select Load on the NanoVNA screen to perform the Load Calibration step. Connect port 1 left and port 2 right to the Through Calibration Standard on the UMSAKAZO board, then select Through on the NanoVNA screen to perform the Through Calibration step. Select Done to complete the calibration process and select Save 0 to save your calibration. Connect the RLC series parallel demo on the UMSAKAZO board to port 1 and you should see the S11 response on the Smith chart. Select S11 Smith from the top left corner of the screen to display the S11 parameter on the Smith chart. The S11 green rectangle should be selected. You can use the cursor 1 to analyze the response. Press on the 1 cursor to select it. Then use stick to move it around the Smith chart and observe how the S11 parameter changes with frequency. Remember, every time you change the frequency range, you must recalibrate your NanoVNA to obtain accurate results. Calibration compensates for losses and characteristics of your measurement system. Connect port 1 to the input, left, and port 2 to the output, right, of the SAW demo on the UMSAKAZO board, and you should see the S21 response on the screen. Select S21 LogMag up right screen rectangle. Move cursor 1 to analyze the S21 response. Select Display from the main menu to enter the display settings again. Select Scale to adjust the scale settings for the S21 LogMag trace. Connect port 1 to the 33 ohm demo component on the UMSAKAZO board, and you should see the S11 response on the screen. Select Trace from the display menu to configure the trace settings. Select Trace 3 to configure the settings for the third trace, and select Format to change the display format for the trace. Select SWR to display the standing wave ratio, SWR, for the S11 parameter. Now you should see the SWR response for the 33 ohm demo on the screen. The 1.5:1 SWR line indicates the point where the impedance is 33 ohms, which is a mismatch from the 50 ohm reference impedance. Connect port 1 to the input, left, and port 2 to the output, right, of the -5 dB demo on the UMSAKAZO board, and you should see the S21 response on the screen. Thanks a lot. If you like the board and want to support the project, consider buying a unit. Everything is MIT licensed, open source, and open hardware. In future videos, we'll explain the why behind each demo and how everything works. In the meantime, you can keep learning on the project's GitHub. We'll also make different calibration kits for prototypes, do more tests, and use the female header pin area.